Hello everybody. So today we are going to talk about charge and how it relates to atoms and ions. So to start off, I have two examples here for you. I have sodium here, and I've drawn out the sodium atom. So we know that sodium has, based on its atomic number, which is the number up there, has 11 protons, so positively charged protons that are in the nucleus, and it has 11 electrons. So we know that the sodium atom, just like every single atom on the periodic table, in its neutral form, in its atom form, has no charge. And we are going to do the same thing for chlorine here. Again, chlorine, I have it written out. Chlorine has 17 protons, and it has 17 electrons. So again, in its atomic form, it has no charge. So we're now going to look at when these atoms become ions. And both of these atoms very rarely, pretty much never exist in their atomic form. And the reason for that is because of how electron shells fill up. So if you remember, you'll know that electron shells fill up in the order of the first shell has 2 electrons, the innermost shell has 2 electrons. We can see here the innermost shell of sodium has 2 electrons, so I'll write 2 there. The next shell fills up with 8, and the shell after that also fills up with 8. This is a bit of an oversimplification, but this is generally how we say electron shells fill up as we move across the periodic table. So we'll see that sodium already has those 2 inner shells. Has that inner shell filled up with 2 electrons, has the second shell filled up with 8 electrons, but oh no, we ran into a problem here. Sodium, that last shell, only has 1 of its needed 8. So sodium needs to try to get rid of this electron here so that it can have 2 full shells, one being 2 and one being 8. So the way that it gets rid of that is it donates it to another atom, or another ion rather. So once it donates that, we'll erase this here. Once it donates that, it turns into a different configuration. So now instead of having 11 electrons, now it has 10 electrons, and it goes from being in its atomic form to being in its ion form. So now we see that it has 1 more proton than it has an electron, so it has a positive charge. And now we're going to take a look at what happens to chlorine. Again, chlorine, we run into the same issue here, where we have the first shell, we got full. We have 2 in the first shell, right? And then we have 8 in the next shell, so those shells seem correct. But in the last shell, we have 7, so we're missing 1 electron. So unlike sodium, instead of wanting to lose an electron, chlorine really wants to gain an electron. So it will gain an electron from another atom or ion, and that will fill up its shell. So now it has 3 full shells. And we move from having 17 electrons to 18 electrons. And again, that's going to give it a negative charge. So we see now both of these have moved from their neutral atom forms to their charged ion forms. So that's the first step. Atoms always want to have full valence shells. But I'm going to give you another example here of an atom that already has a full valence shell, so it doesn't really need to move into its atomic form. So I'm going to write it out here, neon. So neon has its atomic number is 10, its mass number is 12. So neon, if we write it out, we know, and again, I'm just going to draw it here quickly. We know that this shell has 2, this inner shell, and this next shell has 8. So 1, 2, 3, 4, 5, 6, 7, 8. So we know that it has 10 electrons and it has 10 protons. So we see that in its atomic form, its shells are already full. It doesn't need to gain or lose electrons. So that's why neon is called a noble gas, because it doesn't really ever, it has no need to leave its atom form. It doesn't switch into ions like chlorine and sodium do. So although some elements on the periodic table commonly switch into ions in order to fill up their shells, not all of them do. So neon is one notable example, and every single element that is in that same period as neon is called a noble gas. So they're called noble because they don't really react with much, because they're always satisfied in that neutral atom form. So our next issue is, okay, so both sodium and chlorine here, they've filled their valence shells, but now they have positive and negative charges respectively. So not only do atoms or ions want to fill up their valence shells, but they also want to have a neutral charge. So we're going to go one more step here, and we are going to neutralize their charges. So if we have, I'm just going to write out the equation here. If we have a positively charged sodium ion here, and we're just writing it was Na plus, and we have a negatively charged chlorine atom here, the way for them to basically neutralize their charge is to form an ionic bond. So they form NaCl, and you see when I write out NaCl, you see that there's no charge there because they have essentially neutralized each other. So with these two steps, they have gone from their atomic form, where they don't have a charge, but they also don't have full valence shells, so they're very unstable. Then they've gone to their ionic form, where now they have full valence shells, which is really great, but they have this charge which they want to neutralize. And then finally, to neutralize it, they've formed a ionic bond so that their charge is neutralized. So this is just one example of charge and valence shells and how they are related.